Okay, class, we're going to look at functions and how do we find our ordered pairs. Well, we have a rule, and what looks like a linear equation, we're going to use that to find our x and y, our coordinates, our ordered pair. Now, in class, I know we talked about these, and for example, if the rule is 5x minus 1, for number 1 right here, we have y equals 5x minus 1. Well, we're going to replace x with negative 2, with 0, with 3, and with 6. So 5 times negative 2, that's negative 10 minus 1, well, becomes a bigger negative, negative 11. 5 times 0 minus 1, well, that's 0 minus 1, or negative 1. 5 times 3, that's 15. 15 minus 1, I get 14. And 5 times 6, that's 30, minus 1, that's 29. So these problems, we've seen these problems before. We're just plugging in what x is, and we're given the inputs right here, and solving for y, and we get our ordered pair. So all of these would be this would be a function right here, because in the end, what I'm trying to figure out is, does each x only correspond with one y? Now you notice that right here, I have negative 2, 0, 3, and 6. None of those repeat. Over here, none of these repeat. Right here, none of these repeat. And again, so when I work them out, I'll get different y's for each one. But as we continue down the page, you'll see it says determine if each relationship represents a function. Now, if we look at number 5, it says y equals 1/3 x, let me make sure what the problem was, minus 2/5. Well, let's say the input is going to be 3, 6, and 9. Okay, so that means my ordered pairs would be 3, 6, and 9. Now I need to find y for each one. So y is equal to 1/3 times 3 over 1, or 3, minus 2/5. Y is equal to 1/3 times 6 over 1, minus 2/5. And y is equal to 1/3 times 9 over 1, minus 2/5. So right here I would get 1 minus 2/5, which would give me 3/5. Now, to simplify that a little bit more, I want to put that 1 into a fraction form that I can subtract 2/5 from it. So what's the same as 1? Well, 5 over 5, because I want to have the same denominator. So 5 over 5 minus 2/5, well, I get 3/5. Right here, I cross cancel, so it becomes 2, so I end up with 2 minus 2/5. I end up with 1 and 3/5. So you start to see what's happening here. This becomes 3, 3 minus 2/5, and I get 2 and 2/5. Sorry, 2 and 3/5, sorry about that. But what I'm also seeing that is happening anytime I use 3, 6, or 9, I'm only going to get 3/5, 1 and 3/5, and 2 and 3/5. I won't put in 3 again and get a different number than 3/5, because every time I plug in the 3 where the x is, I get 1, and when I subtract 2/5 from 1, I get 3/5. It never changes. So, this is a function. Now, when I look at the information here, I'm given my coordinates. I'm given my ordered pairs. 1 and 6, 2/5, 1 and negative 6, 2 and negative 5. So to identify if we're given ordered pairs, to identify if it's a function or not, what we want to do is say, okay, let's look. Are any of these repeating? Well, I see that x is 1 twice. What is the value that's across from it? 6, negative 6. Well, the rule is that any x value should only have one y value associated with it. So it cannot be 1, 6 and then 1, negative 6. So right then and there I know it's not a function. Now if I look here, do any of these repeat? No. Since none of those repeat and they all have one value associated with them, this would be a function. Now, let me open another page. You know what, let's do this in black instead. You know what, let me get another page instead. Here's my X, here's my Y. Okay, so let's say I have 1, 0, 1, 0. Okay, it's not because X repeated that I decided the other one was not a function. Right here. It's because I did have X repeat. Now, if you look also right here, 2 repeats, and it has 5 and negative 5. Again, that makes it not a function. If it repeats, it has to have the same Y for both of them, and I'll show you what I mean right here. Okay, not that one. So let's say Y negative 2, 0, 3, Y negative 2, 0, 3. Well, because this is the same, that's okay. Nothing wrong there. When I look here, 0, 3, 0, 3, guess what? Okay, it's okay. Doesn't matter that it repeated. What I'm looking is, do they have the same things here? If so, yep. A function. And sorry for the rush on the writing. Now, what if this happens? I'm going to use the same numbers, okay? Y, 1, 0, 1, and 0. Okay, well, 0, 5, 0, 5, guess what? That's okay. 1, 2, 1, negative 2. This is not okay. This makes it not a function. And tomorrow what we're going to do is we're going to continue looking at this idea. And as we continue, it'll help us understand more when we're graphing whether it's a function or not. And as we graph it, we'll see that it's not a function. Okay? So, there is the same thing that we did last time, which was when we were working with linear equations. Plugging in for X, solving for Y. Should be pretty easy. This right here will finish in class. But now you have an idea of, if we're given the information, like the values, we can, sorry about that, we can go ahead and look, and given this, we can figure out if it's a function or not. And we'll have a little bit more practice on this with this tomorrow.